Hello, for this video, we will discuss the air refrigeration cycle. From the name itself, it uses air as the refrigerant, and it consists of two isentropic processes and two isobaric processes. This is the diagram of the air refrigeration cycle. Ano yung difference niya? It uses a cooler instead of a condenser. And then, it uses an expander instead of a throttling valve or an expansion valve. As mentioned, merong dalawang isentropic process, yung isentropic compression and isentropic expansion, and may dalawang isobaric process, yung absorption ng QC from the cold temperature reservoir, and isobaric din yung release ng QH to the high temperature reservoir. The energy balance, same. Okay, we use the same equation for work shaft, QH minus QC. But we can use yung MCPDT for air to calculate yung QH at QC. So that's the air refrigeration cycle. Ganun lang kaigsi. We now move on to the liquefaction process. Liquefaction is the result when a gas is cooled to a temperature in the two-phase region. Gases can be liquefied by the following ways. First is heat exchange at constant pressure. Next is expansion of a gas in a work-producing device, and it can also be done through a throttling process. Liquefaction is used for various purposes. For example, liquid propane, they use LPG sa bahay. Yun. So that's liquefied petroleum gas. And yung sa mga maliliit na sa camping na mga lutuan, it uses liquefied propane. And we also use liquefaction sa transport ng natural gas kasi mas madaling i-transport yung liquid compared sa gas. And we also use liquid nitrogen for refrigeration, for cryogenics. We use gas mixture of air for separation into when we want to separate yung components ng air, we liquefy it so that nasa-separate yung components. And we have two types of liquefaction processes. We have the lean liquefaction and the cloud liquefaction process. For the lean liquefaction process, ito siya. So first, the gas enters sa compressor. Sa compressor, meron kang work input. Then, it enters a pre-cooler, and then, from the pre-cooler sa cooler. Yung cooler, it acts as a heat exchanger then, and then sa cooler, it will enter a throttle valve, then sa separator. Sa separator, lalabas ngayon yung liquefied portion mo, while the gaseous portion ay iikot sa process. Babalik siya. Yan. So, yung Z, yung fraction ng liquefied gas. Let's do energy balances around the cooler and throttle valve and separator. Let's assume steady-state process na na negligible yung PE and KE. So, we're left with this equation. Let's then assume natin na adiabatic process yung cooler, walang heat loss, and wala ring shaft work. Therefore, sa cooler, delta H is 0. Yun. And because of that, whatever yung pumapasok tsaka lumalabas sa cooler, so we have ilang streams. Hindi lang sa ito, dito tayo dito tayo mass balance. So, ang mga pumapasok ay 3, 8, ang lumalabas ay 6. Kasi, energy balance around the cooler, throttle valve, and separator. So, itong tatlo yon. Itong tatlo yon. Cooler, separator, at saka throttle valve. So, ang mga pumapasok yung stream 8, stream 3, tsaka stream 6. Tapos, lahat ng pumapasok, di ba ganun tayo? So, ito yon yung pumasok, H3, lumabas 8. Teka, tanggalin ko yung mga drawings. Yan. Ang lumabas, dito tayo nag-energy balance. Yan. Ang lumabas ay yung 6 at saka yung 8, palabas sila. Ang pumasok ay yung 3. So, yung baligtad. Pero pwede rin naman, basta lahat ng pumasok ay negative, tas lahat ng lumabas. Lahat ng pumasok ay positive, tas lahat ng lumabas ay negative. Yun. Pero baliktad tayo usually yung convention natin, di ba? Lahat ng lumalabas positive, lahat ng pumapasok negative. Pero same lang yun kasi equate mo lang siya sa 0. Ayan. So, meron ka ngayong equation na may enthalpies ng mga streams. Of course, kailangan mo siyang i-multiply ng mass fraction. Yan. Let's solve this sample problem sa next video. Pero before that, before solving the problem, discuss naman natin yung Claude liquefaction process. Ano yung main difference niya? Instead of throttling valve, meron tayong expansion engine na nagpo-produce ng work. Okay. So, yun yung difference nung Claude sa Lind. Kasi yung Lind ay throttling valve siya dito. Pero essentially, same lang the rest of the process. May separator, lumalabas din yung liquid part, while the gaseous, umiikot ulit, bumabalik sa process. Yun ang main difference ng Claude at Lind.